So I leave the floor to Brian Chege.
Hello everyone. Hope you can all hear me. If you can hear me, please type a +1 kindly. Clearly, if you can hear me clearly. Thank you, John. Thank you, Kazungu. Thank you, Vincent. Thank you, Dennis, Mike, Matthew, Robin, Stephanie, and Emmanuel. Sam. Okay, so I'll proceed. Thank you, guys. My name is Brian, as you've heard, Brian Chege, and welcome to the first day of the summit, which is the summit is a 2-day event which will be taking place today and tomorrow afternoon. We have a pleasure of having 3 guests from Safaricom. The names are Janet Wafubwa, as you had seen before. We also have Matthew Mutiso, and we also have Joyce Wamwea, all from the Safaricom PLC, who are going to be speaking to us today, which is really amazing, and we're really happy to have them here. I've seen Matthew is on call, but we have an apology from Janet Wafubwa, who is on travel, but will join us later, later on the call. So, given that Winnie has already presented to us, thank you, Winnie, for about the Data Science East Africa, which was 20-day bootcamp, trying to sensitize more people on the data science aspects of Python programming, yeah, the statistics for data science, the machine learning, which was a really nice process. And yeah, so I'll be moderating as well with Mabel Karani. Mabel, please say a few words.
Hello, everyone. If you can hear me, kindly say yes or something in the chat box. So thank you, everyone. Thank you, Mandela, Masharia, Matthew, Kazungu. Okay, thank you, everyone. So I'm so happy that you all made it for this Data Science Summit. I'm sure we'll learn a lot from this. We thank you, Matthew Mutiso and Joyce Wamwea, for being here. We are ready to learn what you'll teach us. As Brian has said, apologies from Janet, who will join us later. So from now, let me hand it over to Brian, who will continue the session.
Okay, thank you, Mabel, and also thank you everyone for coming for the meeting today. It's really nice seeing all of you here, and we are going to. I believe there's something from for everyone in this summit, and from our very wonderful speakers. From now, we're going to start directly, and I'll hand it over to Matthew Mutiso, who's going to be taking us through what he has for us today. And I'm really looking forward to hear what he has to tell us. So, hey, Matthew.
Hello, can you hear me?
Yeah, yes, we can hear you. I can hear you.
Well, hopefully, maybe you can also see me.
Yeah, I can see you. You can see you.
I'm glad, and it's a privilege, truly my pleasure to be here. So I am gonna share my screen, and then I'm picking up from what Brian you said. I see you're asking people questions, so if they can see you, if they can hear you, you're asking them to type something. So I'm gonna share my screen, and whatever you can see on the taskbar, just respond with what software you think I have, and that will be the confirmation that you will now be able to, you are able to see my screen. So let me just share my screen. All right, so what are we seeing? Tell me what you're seeing on my screen. Somebody says VS Code. Somebody says Chrome. What else are we seeing? Another person say Chrome. Come on, guys. We're the gamers. We're the gamers in the house. Of course, we have the command prompt there. Definitely, we have FIFA. We have PowerPoint. We definitely have Slack. You guys don't, yeah, of course, we have the Windows Explorer. We have Slack. Somebody says we have a blinking screen. Is my screen blinking? Brian, I guess you're the only person I'm supposed to speak to. Is my screen blinking?
It actually is, yeah.
That's interesting. I may need to pause the presentation and start it again. Or maybe, no, I don't think that's what's happening. Okay, there's a clock. Yeah, definitely. Okay, let me just pause my presentation and resume it. Maybe that's gonna fix the blinking nature of the screen.
Okay.
Now let me know. Peacock feather. That's so creative. Win. That's all Lenovo. That's not on me.
Now it's perfect. It's not blinking
Okay,
anymore.
cool. Right. So yes, there's the Git bash. It's actually Git bash somewhere. Yeah, Vincent got it right. So from what you can see on my screen, you probably have an idea of what kind of things I do on my laptop, what kind of work I do, and from there you can see I game a little bit. You can see I code a little bit, but I'm gonna try and explain with a presentation because hey, there's no easier way to get through some of these things than through presentation. So as you've been told, my name is Matthew Mutiso. Welcome to the Data Science Summit. I would assume, Brian, it is in order to say the Data Science Summit Day 1, right?
Right.
So I am a full-time human being, and sometimes for about 8 hours a day, mostly more, I work as a data engineer with Safaricom. My job entails supporting data scientists to deliver quality output. We can talk a little bit later about what metrics for quality are, but generally, this means building pipelines that automate the model's delivery. So while we are at it, I also spend some time on Twitter, and largely we're not talking about my daily coding experience, like talking about how I was talking to you guys here today. I spent time just liking and retweeting funny videos. So you may follow me, but at your own risk. All right. So if you've seen some of the technology companies, what they do, there's something they call a PPT framework. And this is the people, processes, and technology. And it's a fine balance that will exist in organization where they try to offer some form of service and probably get ahead of other organizations, therefore establishing a competitive advantage. And this balance of people, processes, and technology, I want to talk about it with regards to how I spend my days at Safaricom, talking about tools, the processes, but also some of the cultural, ethical issues that I come across when it comes to dealing with data, especially people's data. Now, I have one personal housekeeping point to make. By the way, I have not started my timer. It's important I know how long I need to take before I bore you guys to death. But I have one personal housekeeping point to make. So in case my video freezes, or in case I seem to get disconnected, Please bear with me. As you know, the usual will have happened. I don't need to say what usual. I will attempt to reconnect within a few minutes. So, this next slide is probably going to elicit some deep emotions. But somebody once said that a data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. To the people who are just starting with data science, I don't know how you feel about this, or even more, to even more experienced people like Joyce. I am sure you have a few things to say about whether, as a data scientist, you feel you know more software engineering than ordinary statisticians. But the point that I'm trying to make here, as you saw in the title of this presentation, I just want to talk about data engineering for humans. And the point that I'm trying to make when I say data engineering for humans, okay, if you went to a group of schools, you may say data, but it is what it is. So the point that I'm trying to make here is we are human first, and then whatever other specialization. And that's why in this previous slide that I had opened, we have the culture at the bottom, and you're gonna talk about a few things there. So you can see my screen, you can see quite a bit of tools, a lot of tools. Each day, maybe as a data scientist, maybe as a hobbyist who loves tech, maybe you are a geek, you are a nerd, whichever word tickles your fancy, you have come across these tools. So in my day-to-day work, I use either of these tools. And deliberately, I did not classify them as anything. But if you're taking notes, you will loosely classify them as either programming languages, remote code repositories, slash source code management. You might classify some of these tools as IDEs, that is the integrated development environments. You might classify some as visualization platforms. You probably might classify others as data platforms. Or generally, you might just classify others as just technologies. So allow me to walk through each of these tools and how I use them. And maybe we can compare notes and you can tell me at the end of it all, what do you use? And maybe you can teach me a thing or two. So obviously, as I mentioned at the beginning, I work as a data engineer and my work involves helping data scientists and deliver models. And the delivery of models, you can say a big chunk of my work is building pipelines. Now, let's jump to probably Hadoop. And I could ask someone to tell me what Hadoop is, but I'm not sure how this is supposed to work. Brian, help me out. Can I ask questions, or do I go all the way and then questions will be asked at the end?
You can ask questions.
Okay.
Yeah.
So maybe somebody can volunteer and tell me what they think Hadoop is. Brian, since you are the moderator, and I can't see my present. I can't see the meet screen. Maybe you can select someone to tell us what Hadoop is.
Okay, so I'll just select a random person. Collins Langat. Or let's start with, does anybody know what Hadoop is? And can explain to us what Hadoop is before selecting anyone.
I think that's a good plan.
Anyone with an idea about Hadoop, please don't feel shy.
I've never seen it. First time.
Yes, Samuel?
I've never seen it. The first time I'm hearing.
Hello.
Okay, for Samuel. Hello.
Hello, Steven here. I think it is a distributed filing system for code and such.
Right. I think that's a good way to think of it.
Hello.
Yeah.
Can I say that it is used for big data?
We can say that.
Can I say that it is used for big data?
Yes, we could say that. It's a bit of a convoluted definition, but we could say that it is used for big data, and then go on and define what is big data. Because I think one of the things that when I talk about human or data engineering for humans, one of the things we need to do is to eliminate complexity in definitions. So the next thing we could probably ask is what is big data. But thanks for those attempts. I think generally we could say that Hadoop is okay. There are different ways that you can define Hadoop, but the simplest way is to say that it's a collection. It's a software library that allows distributed processing. So now, when you talk about distributed processing, what you are talking about is machines, different machines being available to process your data, as opposed to a long time ago when you wanted to handle a lot of data, you had to have a mainframe. So right now you can have what you call commodity machines, small machines, and then this software called Hadoop is installed on each of those small machines, and somehow it knows how to handle the distributed nature of the data, the duplication, all the redundancy things, and also how to handle failure. So when you talk about Hadoop, probably what is going to be of interest to anyone who is trying to get into data engineering, and by extension then working with data scientists, is what you call the Hadoop Distributed File System, or HDFS, which is the service now that lives on top of the distributed machines, and provides high throughput access to the data. The other thing when you talk about Hadoop that you may want to know is something called the yarn. The yarn, by the way, yarn, like, how do we define it? How do we think of it as? Okay, yarn spelling like if you've ever done knitting, that big ball, like, or maybe the thing that is used to do the knitting is called the yarn, and it's interesting to learn that the abbreviations for yarn is the yet another resource negotiator, which means if you have a cluster of machines, they expose their memory, their CPU, and their storage. Yarn is like the OS that manages the resources. And so that way you are able to do Spark applications. Now, shortly, we are going to talk about Spark, which is, as a matter of fact, we might just want to go there. So from Hadoop, let's jump to Spark. Wait, I don't have Spark here. Oh, I have Spark here. So Spark is a unified analytics engine for large-scale data processing. Now, I want to maybe dispel a myth here. You don't need Hadoop to start experimenting with Spark. Now, what you need to keep in mind is Spark allows you to process large data sets. We can also dispel that Spark allows you to process any data set. Remember somebody mentioned that big data, mentioned big data. Big data has characteristics. One of those characteristics is variety. Variety means data could be structured, could be semi-structured, could be unstructured. That's one of the power of Spark. Spark allows you, remember, it's a processing engine. Somebody asked me, what is Spark? Is it a programming language? Is it an OS? What exactly is it? An easy way to think about it is Spark is a, how do I put it? It's like an application programming model. It tells you how to do something. It's like a protocol. Then different programming languages, they write their implementations on top. And that is why I've now written here PySpark, SparkShell, and there are others. So you can access Spark using Python, using the PySpark library, also using the PySpark shell. You can access Spark and write and execute Spark queries on the underlying data using the Spark shell. The Spark shell is based on Scala. That's why I mentioned Scala here. I'll talk about that shortly. You also have specialized shells for R, and also if you just want to write native SQL, you can do that with Spark. I don't want to go to much details, but I just wanted to bring out the relationship between Spark and Hadoop. But just remember, even on your Windows machine, even on your Ubuntu, even on your whatever machine you're using, you're a Mac person, you don't need Hadoop to run Spark. You just need to install Spark. If you use Python, you just need Spark, and using the pip packager or package management tool, install PySpark and you're good to go. So now, let me jump quickly to the programming languages. So every day I get different requests. So for quick things that need to happen, I use Python. The most important thing you need to just note about Python is, and I'm gonna ask everyone, please don't start a new project without a virtual environment. Especially, don't go installing libraries on a shared server if you are not in a virtual environment. This messes up work for everyone. Imagine you are just playing around with TensorFlow. And then TensorFlow depends on NumPy version 1.1, for example. And then somebody else is working with Pandas. It depends on a different version of NumPy. You get the issue, you get the point that I'm trying to bring here. Please, whenever you're using anything to do with Python, use virtual environments. It saves everyone the hassle. And the good thing, of course, you can export the libraries you are working with for a certain project using the freeze functionality. Just import that as a requirement, it's fine, on a different machine and just continue as if nothing happened. However, when you're dealing with the applications, especially when you're writing Spark applications that work with a lot of data, the challenge that comes is some of the issues, the fact that Python is a dynamic language. When working with large projects, it becomes an issue. Some errors may not be caught early, and then Python uses a Java gateway to communicate with Spark, and that brings especially throttling when you're working with large data sets. So for that, we prefer to use Java. I know other people in a team that we collaborate with, they use Scala, but I have to tell you for sure we use this. Now, for VS Code, a lot of people saw VS Code on my taskbar. VS Code is where everything happens. So if I have a quick Spark application I need to test whether I'm doing this in Python or Java, I'm definitely going to do this using VS Code. Now, since this is a data science summit, I had to include this Finance extension. I don't know whether you've heard of it. If you have VS Code installed right now, by the way, I'm not trying to do marketing for Microsoft or any of the creators. I don't even know them, but I love it, and I'll tell you why. If you've done Jupyter notebooks, you know the process that you have to go through to actually run and access a Jupyter notebook. VS Code is a good place to start, and then with the Finance extension, all you have to do is within the same directory that you're doing whatever you're doing, just create a file and have it suffixed with I, Pi, and B. So the notebook extension. When you click on that file, automatically it's gonna open as it would using a Jupyter notebook, and that's a win-win for everyone. I included Visual Studio here because one of the languages I didn't put here is C#. We do some work on C#, especially when we want to develop web applications that users can use. We do that using ASP.NET Core, and Visual Studio is our tool of choice. Now for WSL, as you know, this is the Windows subsystem for Linux. If you don't use a Linux machine, you will notice that most of these tools are natively Linux tools because they are open source, and somehow what I've realized is most of these open source tools, they depend on, they are based on Linux. So the Windows subsystem for Linux allows you to do Linux development on Windows, and that's just awesome because you don't have to dual boot or maintain two machines, etc., etc. Now, Git is a very important tool and for source code management. And on top of virtual environments, this is the other thing that I cannot emphasize enough. But before we get to the emphasis, can we get the difference? Please, please. I don't know how much of me is visible, but I'm gonna hold my hands. Please, can we get the difference? There is Git and there is GitHub. Git is the protocol, is the way it's a distributed source code management tool. GitHub is a source code repository. There are many other source code remote repository tools that exist. And one of those is like Azure DevOps. So here, I would have written Azure DevOps, which was called TFS before, which was called other things before. I would have written GitHub here, GitLab here, Bitbucket. Those are remote repository tools. Of course, IntelliJ for Java, not much to be said. Now, if you do package management, I don't know what your, what your preference is, but for me, when I'm doing any sort of development with Java, I do my package management with Maven. Now, of course, the reason why I include Linux here is it seems all the tools for doing data science, all the tools for doing data engineering, not unless they are vendor-based tools. And I saw one of my apprentices here, Faith. Hi. I know you've worked with Azure for some of the things that you've been doing, and we shall talk about some of the vendor solutions later. But if you wanna get really good at this, you have to understand Linux, some of the commands, how they work, and so you might want to invest some time. So internally we use Red Hat, but locally for development, since I'm on WSL, I use Ubuntu. There are some fundamental differences, but at the end of it all, it's just a few API changes here and there. Then, oh, by the way, if I'm looking at you, or maybe you can take a breath. Whew, talking for a long time. If you see me change my, the way, just change my orientation. This side, I have a screen. That's actually where the presentation is. I just want to make sure where we are. Okay. We have Power BI. We have Apache Superset. Power BI is a business intelligence tool by Microsoft. Apache Superset is an open source enterprise-ready business intelligence tool. Now, depending on the organization you work with, it's good to have an idea of how open source works, because one of the priorities of the organization may be to cut costs. Now, obviously, there's nothing for free. So how they cut costs is for you doing the implementation. Now, these do the same thing, because at the end of the day, I'll quote something one of my bosses ever told me, you might have the best application, but if you have no way of presenting it, you might have the best analysis, but if you have no way of showing it, obviously, as we say, in loosely translated, it's going to be hard small. We have Apache Airflow. Now, the best way to think of Apache Airflow is to think of the SSIS packages, where you have, or maybe to think of, if you've done a little bit of, or maybe a lot of computer science, directed acyclic graphs. So Airflow is pipelines as code. So it allows you to say, start here, aggregate this data this way, move here, aggregate it this way, and then eventually do something with it. So it gets its power from operators. So Airflow has operators. So you can, if you want to think of it from a broad and a sort of integrated kind of way, think of it this way. You have an Airflow installation. It's also a web application that you can access, but it also has a scheduler. A scheduler in case you have a report that you have done no analysis and you have to send out every morning at 6 a.m. Maybe it's sales yesterday, or maybe it's leads generated for the salespeople as they go out. So Apache Airflow will have the pipeline. That pipeline will run a Spark. So I realize I'm in the wrong place. Yes. So Apache Airflow has a pipeline. That pipeline could be a Spark application that runs in the Hadoop cluster to aggregate data that is in the HDFS. All right. Let me make a small correction. Apache Airflow will have the pipeline that can that orchestrates jobs that can run anywhere. It could be reading data from your MongoDB, reading data from your SQL Server, reading data from your MySQL, MariaDB, whatever it is. And then, if that data is persisted onto a database, you can use Apache Superset or Power BI or whatever you use in your organization to display. But this is what we use. Now, obviously, if you're working with something like Red Hat, it has no UI. If you're working with something like I don't know what other server you use, it has no UI. So you need Excel, you need Mobile Xterm to connect. I use Mobile Xterm as my preferred SSH client. The reason why I included networking here, it's not the networking of, I saw at the beginning there was some of the missions of data science East Africa where it's networking. I'm not talking about that kind of networking. No. I'm talking about the networking that has to do with understanding how packets move from one point to another. I'm not saying it's an absolute necessity as a data engineer, but it will be nice to have when you have your Spark application, or maybe when you have your Apache Airflow unable to communicate with your Hadoop cluster. What do you do? Where do you start your troubleshooting? A common statement that we usually put is, when you get there, ping me. You need to understand what is ping. You need to understand tracer. You need to understand sockets, ports. You need to understand a bit of SSL, so that's a bit of security. Oh, I included it here and here. Okay, yeah, clearly. They didn't do proofreading for my presentation. Brian, that is on you. Then I'm going to skip over to these other things. So obviously I've talked about this. Estimation for data and for work. What do I mean? You've been approached by somebody in the business, and that is something that I've seen happen so many times. They come, they tell you, I need you to deliver this product. I need you to deliver this model by Friday. Mind you, it's Thursday. What do you do? So that, I'm talking about work item estimation. How do you, with a pinch of accuracy, estimate how long it's going to take to deliver whatever you're supposed to deliver? So I would say this is something that takes time, experience, but don't be afraid to push back, because the problem that I've seen is when you don't push back, you will deliver something that is substandard, and we know how that goes. You're going to lose credibility. As a data engineer, it would be important to understand the details of data estimation. Now, when I talk about data estimation, recently, I don't know if any of you has ever faced, you inserted a row into a database, and you got an saying that that row is too large for that database. And that is where estimation comes in. You make a request. As a data engineer, some of the people, and we're going to talk about collaboration shortly. If you work in a big organization, okay, if you work in a small organization, you may not have the issues of collaboration because you are the alpha and the omega. You provision the VMs, you install the software, you run whatever you run, you host it. But if in a big organization, what's going to happen is there's somebody who provisions the machines for you, the hardware, or maybe the hardware in a virtualized manner is going to be different. So one of the things they're going to ask you is, give me the specifications. How do you come up with a almost accurate figure for say disk? Because the specification you're going to be asked is the compute and storage. Compute is the RAM and the CPU cores. So in this case, we would say I need a server that has 20 cores, that has 100 GB memory for argument's sake, and then maybe has 1 TB. So if somebody asks you, why 1 TB? How do you go about that? I don't talk about that, but I think that would be content for another day. How to estimate data storage. Now, last but not least here, if in everything you do, you don't use Stack Overflow, please raise up your hand, because I know I am not alone. And that is why I've triple starred Stack Overflow. It's a good tool. As a matter of fact, I don't remember a day that has gone by without me using Stack Overflow. But that aside, Stack Overflow is not the only tool that you can use. And I'm going to go back to maybe all these tools that I've talked about. For example, if you're facing an issue with your code in Python, it might probably be easier for you to go back and read the original documentation from Python. It's not opinion, it would be a fact. They would be telling you, you're using Python 3.6, you are trying to do something, and the documentation for that method is available there. If you're trying to do something with Spark, you could go to the spark.apache.org website, and there they will have the proper documentation. Now, the thing that I'm trying to emphasize here is going back to first principles, understanding the root. I have encountered many people who have been asking me, I want to jump over, I want to pivot into data science, I want to pivot into data engineering, I even want to start coding. Then they join these classes which immediately jump them over into data science. So the question is, if you are told the first class you do is from import pandas SPD, what do you mean by that? Can you possibly unpack what we mean by what is pandas? What is PD? Why are we saying us? And if I need to read, I say pd.read_csv in brackets, the file name. Where does the file load? What is the DF that I have assigned? What is a DF? By the way, a data frame is different in Pandas and in Spark. Spark also deals with data frames, but they are different. And one of the, of course, fundamental differences is in Spark, a data frame is distributed and in Pandas, it's not. All right. This is, I'm going to jump over these things because now, obviously, okay, I don't know. We shall see. So one of the problems we face with this field of data science, you can call it machine learning, you can say AI, is we don't have a mature methodology of doing things. Now, Google has attempted to come up with a description. There's a link. If you just search ML ops, as in machine learning ops, you will see they've come up with a good methodology that defines how machine learning continuous delivery should happen. But our process is fairly slow, and for good reason. If one day you wake up and you are trying to look for a service from us and it's down, it's going to be a problem. So we have some checks and balances, and those are the processes that we are bound with. So if something is new, somebody like Joyce will talk to the business users, and that is at the inception stage where a model is trying to be developed. And this is an iterative process until they get it right. So just trying to understand what is the problem, what are we trying to do. If say we are trying to understand something like, I don't know what I can mention here without violating my non-disclosure. So let me just stick to generics. So after the inception, which you can see is clearly driven by business users and the data scientists, we then move to an area of development. Now, development is the part where we identify in a large organization, even in a small organization, data might be in different places. There's a common word you will cross, it's called silos. So there are organizations that have silos. So for those silos, we try to ask, where is the data? How can we get it to a central place? Remember Hadoop? How can we get it to Hadoop? How can we get it to a data warehouse? How can we get it to a data lake at the very least? Because you'll find different divisions, different teams will have their data mart. The data mart is the small one. Then you have the data warehouse, potentially the mammoth of the data lake. When that is done, with the check green light given by the scientists, the data engineers now will build the pipelines and automate them using the different tools. This is the part, remember Faith, I mentioned earlier? This is the part where she told me they use, at some point they used Azure Data Factory. So if you are a Microsoft person, or you live on the Microsoft stack, there are different tools that they provide. So, and also I mentioned you don't need Hadoop to store a lot of data. I'm avoiding deliberately using the word big data. If you have a lot of data, you own Microsoft, you own Azure, you can use the Azure Data Lake. If you're on AWS, you can use S3. You can use Spark to access that data. For deployment, we will have the data engineers and the support team. Now, the challenge we faced here is because we are not many. And so we are violating a small principle in software engineering that says, if you build it, you run it. But the problem here is there are so many things to build, you can't possibly build everything and run it. And so after the development of the pipelines and the models, that is handed over to the support team that runs, and if there are things that need to be changed, this might come back here for maintenance and still managed by the support team. Finally, I just want to talk about culture and ethics. So let me start with the team dynamics. You are a new guy When I say guy, I mean either or. So you are a new person in the team, and you've come in first class, awesome problem solving skills. You are given this small project to do, or at least what you consider to be a small project. How do you manage that? So I'm going to talk about a few pitfalls that I've seen young developers, junior developers, or just somebody starting out do that could be avoided. It could be very helpful. Now, one of those is entitlement. Should you join a team, I think it makes a lot of sense to sort of sit back and see what is happening while doing your best, not feeling that need to be at the center of the action. Because the thing that happens is when it becomes about competition, it becomes a bit hard to build relationships. So you might be given what you consider in your own terms a small project to work on, but even then, do the best that you can just to understand how things operate. Because remember, culture is not what is communicated in shiny billboards. It's how the different team members collaborate with one another. I mentioned competition as I talked about entitlement. It's important. Do not compete with your peers. As a matter of fact, if you think about Ubuntu, they are because we are, or is it the other way around? It makes a lot of sense that we uplift one another. And that means just making sure we see stuff get to production. Success for everyone is stuff getting to production. Documentation. I have had developers, I don't know about data scientists, but I have a software engineering background. But these things, they cut across. I've had people hate documentation. I don't know about you. But if there's one thing that you can help yourself, take a course on technical writing, but develop a positive attitude towards documentation. Remember, the title of this presentation is Data Engineering for Humans. We can all write code, no doubt about that. The machines can compile that code, no doubt about that. Can humans read that code? There's also a saying that goes something to the effect of, good code is self-documenting. So if you really struggle with writing markdown documentation, if you struggle with writing documentation in whatever form or shape, please just write easy code to understand. We are not competing. Then there's a bit of course, never settle, never, how do they say, Brian, remind me, how do they say it? Steve Jobs was saying it. Stay foolish, something.
Yeah, I remember that one too.
Stay foolish, stay
hungry.
Yeah.
Stay hungry, stay foolish, yeah.
Yeah. So, and I think by being in this summit, it already shows that we are trying to continually stay hungry and foolish. So now, I'm assuming that some of us are at the beginning of our data science journey. Some of us are continuing with our data science journey. Either way, I cannot emphasize enough how we need to continually improve on anything that we are doing. Now, finally, allow me to talk about epics. Now, in light of the Data Science East Africa mission to improve data science, one of the things that you're gonna be faced with is exposure to a lot of data, personal data about things. Now, that data could be catastrophic when placed in the wrong hands. You will be seeing that data every day. If you work in an organization that handles, say, you are in healthcare, maybe you work with the smart, you can tell who is going to hospital. You can probably tell what they are being given. If you work with Safaricom, you can tell who is being sent money. If you work with, I don't know, but you get the point. You are being exposed to data. And while we can talk about GDPR, remember, there is loose enforcement in this country. So it goes down to ethics. Where are your ethics? How are you handling yourself with exposure to this data? But that is personal. Let's talk about some of other things that come along. For example, there's this lady who just got fired from Google because the research she was involved in shown that the amount of carbon emissions that are happening as a result of model training and retraining is far more detrimental to the benefits of building those models. She got fired. Those are issues to think about. We could talk about something like bias. I'm sure the data scientists will cover bias better than I would. But how do you handle bias? In that, like one of the things that was also mentioned at the introduction was, this is an inclusive place. It's an equal opportunity summit. It's an equal opportunity NGO. But that is the declaration. How do you ensure equality in your models through training the data by making sure you subject the data to checks and balances that eliminate bias, that ensure a person is not going to sleep hungry because their credit was not approved because a model biased against them because of their age, their gender, the color of their skin. We could go on and on and on. People, thanks for listening. Thanks for watching. I am sure you might have some questions. I will be right here. Back to you, Brian.
Thank you so much, Matthew. That was really amazing. I've really learned a lot. I'm a data scientist myself, but I've not been knowing about the Apache and the Spark. Yeah, it was really nice. Yeah. Anyway, does anyone have any question that you want Matthew to answer? At the moment, let me be looking at the chat.
Hello. Can you hear me, Matthew?
Yes.
Actually, I have a
yes,
question.
Walter.
Oh, thank you, Matthew. So,
yeah.
You know, actually, I'm on a data science class and I'm doing Python. So, learning it as a data science. So, I'm thinking, so when I want to use big data, for example, with a lot of varieties, do I need also to learn Hadoop or Spark?
Definitely not. As a matter of fact, there's a popular saying that says that you actually don't need a model to deploy your application. Actually, I might be a bit, because this is a room full of data scientists, I might be a bit extreme and say there are many places where rules are better than models. Where models can take you is much better than where you take models. So you only use models when it's absolutely necessary. And as such, you don't need Hadoop, you don't need Spark to deploy a model. There are other simple tools that you can you can use for that. And I've just touched on some of those there.
Oh, thank you.
I also have a question about the Spark and the Hadoop. Say we are trying to create a smart building, yeah, where the data is all collected from
smart building.
yeah. So say we have like fingerprints by the door. We have camera sensors which have like take your images and everything. Try to recognize who each and every person entering the building and such. So where does Apache or Spark come into? Where do we deploy it when trying to create this kind of a smart building? Yeah. So where does Apache and Spark come into? Because I was a bit confused by that. I don't know how it's used in Safaricom, and I'd really like to know.
Yeah, so what you're talking about feels like a bit of it's a bit real time, and I don't think Hadoop would be the best use case there, because remember, I think there's one thing I didn't mention very well, and it's how do you end up having a data lake? Hadoop can be considered a data lake if you set it up as such. So, but what you're talking about is probably an IoT application where you have some sort of cameras, they capture image, they send the image somewhere, and on the back of it, what you have is a sort of a recognition engine that does computer vision processing. So at that point, what you probably need is TensorFlow that captures those images. What you could have Spark, and you could have Spark running TensorFlow model, because one of the things that Spark supports is what you call let's call it inline scoring. So you would be able to do the scoring in real time and store that data somewhere. So definitely you don't need Hadoop. Now there's a conversation that we can have around how do you do your estimation so that you determine whether you need Hadoop or not. And definitely for us, we need it, although the details now would be a bit subject to non-disclosure.
Okay. So the part that you say that the TensorFlow will be running in Spark. So how do they come around? Like, is it like the TensorFlow kind of the Spark kind of separates this data into their right format, in their right, say, like if it's textual format, it's in a special place, or image, it's in another place, or what really happens, like with the Spark?
I see what you mean. So and any other person who is a bit vast with some of these things can correct me if I'm wrong, but everything, I should have brought that demo. I had some demo around computer vision, but everything that you have to do, remember we are dealing with the computers, gets reduced to numbers. So even when that camera captures the image, that image gets converted to some sort of numbers. Those numbers are the ones that are going to be passed along, say something like a pipeline, like a Kafka, like a queue, like Kafka, and then Spark would work on that as the numbers. Because at the end of the day, when you talk about something like TensorFlow, you're talking about deep learning, and that means you're talking about neural nets, and it's just a matrix of numbers. So you can think of an image as you can think of, like, if you look at everyone who is on the screen, just a matrix that has maybe 1,000 by 1,000 pixels, and maybe a representation of on the RGB scale, something like that.
Oh, okay. Thank you, Matthew.
I can see some people asking some interesting questions here. Do you want me to go through those? Brian?
Yeah, I don't know whether I think we are kind of running out of time. But
Okay.
yes, you can
Okay.
answer
No worries.
you can answer a few like four, yeah.
Okay, so somebody asked if you can learn data science in one day. I definitely think not. I started well. Yeah, so definitely no. And somebody else asked the same question. Definitely no, you can't. Somebody said I briefly explain my journey. So briefly, I will explain it. I have been in the tech industry for 8 years now. I am an undergraduate of JQuat with a degree in IT. I am CISA certified Information Systems Auditor, and I have a master's in specializing in business intelligence from Strathmore University. And going back to the question of can you learn in one day? Clearly, even with my master's, there are so many things I don't know. So clearly, you can't do that in one day. So I jumped into data engineering 3 years ago. And well, I would say I was working in the IoT space and we were dealing with a lot of data. So it felt like a natural transition. So I learned Python, I learned a couple of other libraries and tools that I've talked about and others probably that are not here. And that's how I ended up being in the data engineering space. I don't see any other question. Somebody is asking about ML and DS, and I think if you were to draw circles, if you've ever seen the Ikigai kind of circles, if you were to draw circles, DS would be software, based on also the definition that I gave earlier. There would be DS would be a bit of software and a bit of statistics. And if you were to do machine learning, you could say a bit of DS, but also a bit of software engineering, because with machine learning, what you're trying to do is to get the machine to learn, and a good example would be the computer vision. That would be like a good example of that, because it's easy for you to see and say, yeah, this is Brian, but how do you tell the computer to know? How do you teach the computer that this is actually Brian? And that would be now the arm of DS, that will be machine learning. I think that's it. If there are no further questions, thanks guys for having me. It's been an absolute pleasure. And stick around just to hear what the other speakers have to say. Back to you, Brian.
Thank you so much, Matthew. It's been a pleasure to hear from you. I've really learned a lot from the data engineering that I didn't know about. Yeah, and I believe everyone in this room has also learned a lot from you. It has been really nice to hear from you. So we'll invite our second speaker for today, who is Joyce Wamwea. She's also a data scientist from Safaricom. I believe she's here as Joyce Wanjiku, if I'm not wrong. Yeah, I can see her. Hello, Joyce. I think you're on mute.
Hi.
Hi.
Yeah. So just a sec. I think let's make this section interactive. Can you see me?
We were seeing you, but now we can't. I don't know whether to everybody.
Oh, oh God. I think just let me set up. I think my okay. Perfect. You can see me now, right?
Yeah, we can see you. I hope everyone else can also see her.
Yeah.
Please type
Perfect.
+1 if you can.
Perfect. In the chats, I see yes. So my name is Joyce. I currently work as a data scientist in Safaricom, and I want this section to be very interactive. I'm learning that we have a couple of data scientists in the audience. I just want to have a feel of who is present. So kindly, could you write in the chat what you do? If you're a data scientist, software engineer, if you're still in school, please indicate that. That will guide me as to what to focus on. Kindly, please. We have 1 minute to do that. Students in machine learning, still in school. I'm reading out what you guys are writing, so please, data scientist, okay. Um, Student, software engineer, data science newbie, still in school, scholar. Keep going, we have 1 minute. Student in data science, still in school, junior research analyst, wow. Machine learning and AI school student, wants to pursue DS. Data scientist, software engineering, perfect. I think from what I'm seeing is that most of you kind of understand what you're in technical fields, and most of you somehow understand what data science is. Okay, so for a second activity, let's try and define what data science is. What do you think data science is? Let's go. Just type something. What do you think data science is? Hi, are we together? By the way, feel free to unmute your devices. I want to hear from you guys. At the same time, you can chat. Let's go. Getting insights from data, drilling of data. Getting insights from data. I need another definition, guys. Analysis and learning of data. Analyze data. So guys, the definition you're giving me, you're all saying analyze data, get insights from data. What do you think then is the difference between a data analyst and a data scientist? Somebody keeps. What do you think?
Hello.
Yes.
Hi, Joyce.
Yeah.
I think
Yeah,
a
data. I can hear
Can
you.
you
Go
hear
on.
me?
Yes. Loud and
Okay.
clear.
I think data analysis is a subset of data science.
Okay.
Because data science, I think it's somehow like a concept that unifies data analysis and the algorithms used to analyze the data itself, presentation, and all those mathematics and statistics and everything. But for data analysts, I think they just analyze the data and they present it.
Okay. Okay, that's a good response. Let me see what guys are saying. Data science entails tools to analyze big data. It's the practice of collecting data, analyzing, telling stories. The field that deals with solving business problems. True. I think what Walter has said, there's some truth to it. Data science sort of encapsulates what a data analyst would do. But the way we like to think about it in Safaricom is data scientists, we mainly focus on the future, whereas data analysts focus on the past. That is, they're looking to generate reports and understand how maybe the business performed in November, in October, in the last 1 year. Whereas we as data scientists are looking at how do we expect the business to perform in January next year? How much money do we think this customer is going to give us? And then from that, from those insights, from the two teams, we can combine and come up with products that better serve the customers. Does that make sense? Quick yes, no, more explanation qua chat. Let's be interactive. Okay, I can see yes. Thank you, guys. So yeah, I think I'll talk a little bit about my journey. I started out as a software engineer. My background is in computer science, and then quickly moved to being a data analyst, and now I'm working as a data scientist. So that's my background. But the interesting thing is I work in a team of 7. And at the moment, it's very interesting. We come from very different backgrounds, with some coming from a statistical backgrounds. I have people in my team who did applied stats in campus. I have people who did engineering. In fact, one of the ladies in my team did electrical engineering. We have people coming from IT. We have people coming from computer science like myself. And the point I'm trying to make is, it doesn't matter where you come from, you can still enter into the field of data science. And the thing about it is when you come in, you should look to capitalize on what you're good at. For instance, I'm good at technologies, I'm good at scaling, so I might not necessarily rely so much on the data engineers. But at the other hand, I wouldn't say I'm as good in statistics as some of my colleagues. And so there is that kind of interactions between us where we learn from each other. Tuko pamoja na monitor chats kwa na hivyo together. Somebody just type a yes. Okay, thanks, Dennis. So I don't know. Let me talk about the kind of problems we as a data science team deal with. The first one being the category that is most famous to you guys. I saw people talk about data science and machine learning, so I'll talk about the first category of problems we work on, and that we do predictive analytics. Predictive analytics is leveraging machine learning to try and predict the future, and hence, with that kind of understanding, we can better serve our customers. So there's that category of problems we deal with, and as an example, one of the interesting models we've built as a team is like a forecasting model, which sort of tells us how many calls we expect in our call center in the coming week or even tomorrow, and then we can now plan our call agents well. With that kind of information, then we're able to plan accordingly for the needed agents. That's just one of the examples of problems we work with. We have a ton. We are also working to optimize our network using machine learning. We're also looking at the different kind of product offering we can give to our customers, obviously by trying to better understand our customers by leveraging machine learning. Then we're able to deliver better products and a better experience to our customers. The next, and that's I think when most people hear about data science, that's what they think data science is all about. And for sure, a big chunk of our work revolves around that, but that's not the only thing data science is about. And this brings me to the second category of problems we look at, being we conduct a lot of experiments. I don't know if anyone here has heard of A/B test. Let me just get a feel from the chat. How many guys have heard of the word A/B test? Guys, I'm waiting for your feedback. Let's be fast. I have. Matthew is biased. Matthew has heard all these things. Nope. There is a one, yes. Yeah, so guys, if you're interested in this field, wow, this is very interesting. Most of you guys have not heard of A/B testing, and this is another category of things as a data scientist you need to understand, and this is where now we really leverage on a lot of statistical knowledge. A/B testing is just, as a data scientist, you can be presented with a problem between A and B. Which one do you think is better? Let's take an example of my Safaricom app. Between this current user interface and this other type of user interface, which do you think is better? As a data scientist, it's your job to answer those kind of questions. And that's where now you design the experiment you conduct. You say 50% of our traffic goes to A, 50% of our traffic goes to B. And then now we analyze that data, obviously after a certain level of traffic has seen the two experiments, and the experiment has actually reached something we call statistical significance, assess the results and decide, okay, I think A is better for our customers rather than B. Tuko pamoja? Heard of it now, sawa. Wenye mmesikia sawa. So that's an assignment. Go look into A/B test. It's also a key pillar, and not only A/B test. That's just one of the example of experiments we run as data scientists. So I think I'll quickly move on to our third category. As most of you know, data scientists also do some of the tasks data analysts do, and we have something we call root cause analysis. This is where, like for example, business will come and ask you, Joyce, why do you think there was a decline? There was a 10% decline in the send money transactions that happened last month. This is something we call. Sorry, there's someone. Okay, that's Sawa. Thank you for meeting. So this is when now you as a data scientist will sit down and try to understand, look at answering this question using data, and you have to look at very different aspects. It could be the economy. So you're not only looking at the internal data you have, you're also required to look at what is happening within your environment in order to answer that question. So it might be that the economy was down. For instance, this year, because of COVID, obviously, our business was also impacted negatively, and you should have such kind of thinking as you're trying to identify the root cause to answer that question. I hope I am clear on the three types of problems, three as data scientists in Safaricom work on. Kwa chat, I need people to tell me bado tuko pamoja. You can also start raising questions. You can also start raising questions as to what you think I should tackle. I want you guys to direct my conversation. I don't want to talk too much, share too much, and lose you. So let's make this session interactive. So let me just touch. I know you guys have heard that as a data scientist, you need to have a little bit of programming knowledge. You need to know a little bit of statistics. There's calculus, linear algebra thrown in. What else? You need business knowledge. And for sure, all these things are relevant. But if you're looking to start, I will advise, obviously, the fundamentals. You need to be able to manipulate data using code. And the reason we use code as opposed to Excel is just because of scale. Excel has a limit as to how many records you can actually open without it. But when you come on the other end to manipulating data using code, it becomes very fast. And that's why programming nowadays is a requirement for data scientists. And so you don't really need to go deep and understand advanced concepts. I don't know, like how to make network, like how to handle open ports. I don't know what. They will come in handy because I also deploy my work on servers and I work on servers. But as a start, all you need to do is just, can I be able to load my data? Can I be able to do an analysis of the data? Can I be able to visualize this data? Those are the kind of, that's the kind of programming knowledge you need as a data scientist. So when it comes now to the math knowledge, that's the statistics, calculus, linear algebra, those are the core things. For statistics, the way I've approached learning it, because even for me, coming into this field, I was coming in very strong in software, but not necessarily strong on statistics, is most of my learning has been through the challenges I've worked on. So I will get to a point where I'm looking at the data, I want to visualize it in a certain kind of way, and then I'll go look, okay, what visualization fits my data? This is categorical data, or this is ordinal data. What kind of chart fits my data? And then I'll go learn how to do that. That's for statistics. Now and I know people throw in these terms, like you need to understand calculus, you need to understand linear algebra, but they barely mention where they come in. if you're working as a data scientist. And let me just try to break it down. Calculus, for those people who have an understanding of machine learning models, you've encountered something called gradient descent, which is how these machine learning models are able to optimize and actually learn the best parameters. So if you're looking to understand the inner workings of those machine learning models, the branch of calculus which you require is optimization. You don't need to go learn the entire calculus. Some things don't even apply to us. All you need to understand is differentiation, integration, optimization. How optimization leverages on calculus. How it leverages on calculus. That's it. Linear algebra, how we apply linear algebra is my data. If you look at the way our data we have rows and columns, and if you just look at it, those are like points in a dimensional space. If you're thinking about it, if you've attended a linear algebra class, you understand that vectors are just like points within space, and we mainly how we apply linear algebra is, let me just give an example. If I'm presented with 10 columns, data that have 10 columns, maybe I don't know, 10,000 rows, and I'm told, Joyce, we need to present this data to business. So meaning I need to find a way to squish this data into 2 dimensions. Then I'll go now apply certain concepts in linear algebra that deals with dimension reduction, whereby I can take 10 columns and reduce them to 2 columns, and while still maintaining the core, like the relationship between the data. I'm not losing the essence of the data by squishing the data. And for that, I leverage, if you've attended a linear algebra class, you've heard of things like eigenvalues, eigenvectors. Yeah, so basically what I'm trying to get at is, when you hear that data science requires linear knowledge, be very specific. Understand what is it in linear algebra I need to learn. Don't just start learning blindly. There are specific things which we leverage on, and those are the things you need to focus on learning. Same thing with statistics, same things with calculus. So don't be intimidated, just go look at the specifics you need to learn and start there. I think I've done too much talking. Let me go to the chat and hear how it's going. Tell me, guys. Are we together? Yes, no? I'm waiting. It's nice. Thank you. So Peter, yes. Can I now start getting questions? I think I've talked a lot, and I'd want to get a little bit of feedback from you guys, and direct me as to what to talk about. So, do you develop models such as, say, predict things like Safaricom app are likely to be hacked to gain access? Okay. In terms of security, we are just starting to work with the security team. We haven't done that yet, but I know as of last week, we had a discussion with the security team as to how we can introduce machine learning to monitor some of our processes. So the answer is no, but in future, yes, for that. Other than A/B test, you use, so for us, mainly, I'm going to be very candid. The only type of test I have been able to run currently is A/B test, but I'm aware that other tests do exist, and it's actually something I'm supposed to be learning. But most data science roles will require you to understand A/B tests, and A/B tests can have many variations. It doesn't necessarily have to be just you're comparing A and B. It can be you're comparing A, B, C, D, F, G. Like you can have like 20, 50 variations. And for that, now you need to understand how to conduct, how to size your experiment, how many people need to see this experiment before I can say that my results are actually not due to chance, they're due to, there's an actual effect in the experiment. So I am aware of A/B tests. I know there are other tests, but as of the moment, we mainly use A/B tests. But can you but you can about the knowledge needed. Stephen, Chacha, I need you to rephrase your question. Is Zuri? Yes. Zuri is, in fact, one of my colleagues is actually working on making Zuri intelligent. Yes, Zuri is an NLP product, but now we're actually trying to train a model using LSTMs. I don't know if either of you guys have heard about LSTMs. It's a type of neural network. Yeah, we're actually trying to train the model to auto learn. NLP is not very good at learn. Actually, it doesn't. Let me just say it doesn't. NLP is just, it helps you understand, like if I type niaje, sema, to just match it up and say these are greetings, but it doesn't really help in self-learning. So for that, we're trying to leverage neural networks more to make Zuri be able to auto-learn very fast. Cloud providers, do you use cloud? No, we do not. At the moment, everything is in-house. In terms of the tools we use, there's a tool called Dataiku that makes our life very easy when it comes to building pipelines and experimentation. It's just a tool that makes me, rather than going to scikit-learn or Keras or TensorFlow or whatever libraries exist out there, it's just a tool that has rebuilt these models. And so what I need to do is just feed it the data and then now look at the predictions it throws. And I also now can be able to experiment on 10, 15 models at the same time and see which one actually throws the best result. And I think something I need to mention is most of you think data science is all about picking a data set and just feeding it into a machine learning model, but there's a lot to wow, really? Okay, sorry. There's a lot to data science, and I will say just feeding in the data to the model is actually the last part of what we do. There's a lot of the data we get is very messy. There's a lot of data cleaning. There's a lot of doing like you need to figure out, is this data answering my question? Sometimes you have data, but it's not necessarily, it doesn't have a signal to the process, to the problem you're trying to solve. So one of the key things you need to identify is this data helping me, or is it detrimental, or it doesn't really help? Sometimes, especially for beginners, you might find a model that is leveraging, I don't know, 100 features or 20 features, and in the real sense, you only need 5. So as a data scientist, it's upon you to understand what features are helping my model, meaning they are making my accuracy score go up, or whatever metric you're looking at, what features are actually making my metric go up, and what are not affecting at all, and what features are actually detrimental to my model. And there's a whole thing about feature engineering, which is a very broad topic, and I think you should look into it. Sometimes you might get data in a certain way, but if you convert that data into another dimension, for instance, I have the weight of people, but if I was to square that data, or if I was to do an x cubed of that data, it actually performs very well, as opposed to having the data as just linear data. So feature engineering is something very key, and I will say that's where we spend majority of our time as data scientists. It's in trying to figure out what data answers the question I want answered, and how can I optimize these features. Meaning, if I play with dimensions a little bit, will I get a good performance? I've talked too much again. Let me go back to you. Are you a self-taught data scientist? What path or what qualifications? Yes, I am completely self-taught. As I said, I started out as a software engineer from school. Started learning a few things. Worked as an analyst for a while, just doing basic data analysis, and then moved into data science. And while I was moving into the field, I didn't know most of the things I know today, and I am very, very grateful to be in a team a very diverse team with people coming from different backgrounds, because it's really helped me like sort of learn the things I didn't know going in. And I will always insist this, the best way to learn data science is by doing, not by tutorials, not by tutorials are good to give you the fundamentals, but what happens, and I am a victim of this, is we spend so much time watching videos. I don't know, NG or whoever is on the internet. You've watched so many videos, but if somebody was to ask you to break down just a linear regression model, if somebody was to ask you code these linear regression models from scratch, you don't have a clue. You've watched too much, but then you've not gone deep enough. There's something we call the T, and the T is, this is depth, this is being diverse, this is going deep. And I always advise people go deep in even the fundamental concepts, go deep. It makes even learning other things down the line very easy. So learn by doing. It's the most effective way to learn. Yeah, don't spend too much of your time watching videos. And I was victim to that for over 1 year. I didn't think I was good enough to actually do what I do. But as soon as I worked on my first project, I gained major confidence to even now go further and learn. So yeah. Yes, I mentioned Andrew somewhere. Let me see. What models are best for predicting time series data? As a data scientist, I would never ever speak on like a war between models. The way we pick models, it depends on the problem. And again, in some cases, a simple model does best than complicated models. You pick a model depending on the problem you're trying to solve. That's it. I think I will leave it at that. And also in some cases, for instance, we have credit models. Sorry, I forgot to mention credit is also a big part of what we do. And when you're picking a credit model, it has to be a model which you can actually explain to the way to business. Meaning when a business is asking you, how did you arrive at this prediction? You should be able to clearly explain. Remember, this is people's money involved. You can actually be taken to court. So your model just can't fit anything. Like, explaining how, I know we have weights even with neural nets, but some of the neural nets people build are very complex. You can't even begin to start explaining. So again, how you pick your model depends on the problem you're solving and the requirements from business. Do not forget, this is not a science project. You're doing this for business, and you need to be able to explain how you arrive at certain. I hope I'm clear. Kindly mention the tool you use at Safaricom for data science. On a test basis, we haven't really procured officially any tool, but most of my team members we experiment using a tool called Data ICO. I studied data science from high school. I have a lot of experience working with data science, but how can I land a job? Because a lot of people see me as a kid, sadly. Any advice? Wow. So what I'm getting is you're young and you need people to give you a chance. This is not, I don't think this is even a data science problem. This is a problem. This is a problem to do with just having people trust you at an early age. And the way you can make noise is the way you make noise is just let your work make noise for you. I actually had a friend who was 19 years old. And who somehow convinced people to hire him as a software developer. And how he did it was he simply went, and this is quite a very funny story. He went for the interview. They saw he was very young and they were doubting him. And he told them, just give me 2 hours, give me a problem and give me 2 hours. And he delivered within those 2 hours. Again, let your work make the noise. There's no, I don't think there's any other advice I can give you. Just build a portfolio of projects you've worked on and let those projects actually do the talking. Yeah, Prince, I hope I answered you. I hope I have not passed my time. The guys who are facilitating, I want to give the others a chance. Oh, snap. People can't hear me. Bruce, you can't hear me. I thought I'm shouting. Via earphones. It will be better. The tool is Dataiku. Dataiku. It's I think the company is in the UK. It's a startup actually. But there are very many tools. I know there's Nine. There's so many other tools similar to Aiku. Yeah, you can look at them. Just look at data science studio type of tool. What kind of projects make my portfolio better? Wow. That's a very I feel like people work on projects they're passionate about. It doesn't really matter it doesn't actually matter if you have 10, 20 projects, 1, 2. I will say just pick one project which is challenging, work and show value. Another thing we forget to do is we don't know how to sell on the value of the work we're doing. And as a data scientist, one of the key skills you also need to have, you also need to be able to communicate. Just simplify what you've done and explain it to people who really don't understand machine learning and what we do, explain it to them. So my advice would be pick a project you're passionate about and work on it. And I know
Yes. Sasa hao watu wangu hawajakuja na pesa zimeishia maua. Lakini nilikuwa nataka basi chaja yangu nisome.
Hello. Ensure you mute your mic.
It's okay. Thank you. Yeah. Just work on a project. And the thing about, I know most of you guys have heard of Kaggle and you're probably very active Kaggle members. But the thing about Kaggle competitions is the way the data is presented, they've sort of done most of the work for you. And so that might not really be a good project to showcase your skills, because if you're interviewing to be a data scientist, you need to show that you actually got messy data, how you worked through the messiness, the questions you asked yourself, how you dropped some of the features, how you chose to proceed with other features. Those are the kind of questions you're going to get. Why did you decide to use a neural net and not a linear regression model? Whether those are some of the questions you get. What metric are you using to measure success? For instance, myself, I am very heavily involved with the fraud team in Safaricom, and my data is heavily imbalanced. By heavily, I mean like 99 point something percent of the data, these are good guys. And if I want to identify the bad guys, I can't use the normal accuracy metrics we use to measure my success. So those are some of the kind of questions you're going to be asked. And I also can't go pick a neural net. Neural net works very well when the data set is very well balanced. So I need to think about models that are good at picking outliers. So again, onto the part of picking models, it depends on the problem you're working on. And when you're coming to interviews, you need to be able to understand the pros and cons of some of these models. If I asked you a question like what type of model will you use for credit, you need to be able to tell me I will use this type of model, the reasons, the pros and the weaknesses. That's it. And the metric you use to measure if your model is performing well or not. Okay. Take us through the data science interview process. Is data structures and algorithms necessary in data science? For Safaricom, I don't think you're going to be asked those kind of questions. A colleague of mine has actually gone through the requirements. Yet, I'm not going to talk about in future, but data structures and algorithms, for us, they're not core. But I don't know. It's learning about these data structures helps you think even about solutions better. And I'll give you an example. I have been working with graph graph analytics for a long time now, and for me to optimize some of the algorithms, I need to understand how the data is stored, and that's where now the data structures come in. If I know the data is a dictionary, then I can be able to know, oh, if I'm trying to access this data, then accessing it using the key is probably better than any other way of accessing the data. If the data is stored as a list or wherever, I should be able to know to best access what I'm looking for. This is the route I go. I don't need to unnecessarily be doing loops where I can reduce the running time to a constant time. It's good to have, but when you're starting, it's not really key. I know these things because of my background. They serve me again onto leveraging what you're good at. I know that, and so if my team member is trying to optimize something, they might come to me. If I'm trying to learn further about some of the statistical things I don't know, like for instance, what's something like there's so many things in statistics I don't know yet. I'll probably go to some of my team members. So yeah, don't stress about the few things, the minor details. I think I've taken too much time. Am I still? Is there a data structure you need to master? No. Just be good at pandas. If you're good, if you know how to manipulate data frames, pandas, you have a little bit of SQL knowledge. I think you're good to go, and you can actually use libraries like scikit-learn. Yeah, I think you're good to go. Which programming languages do we use most? So in my team, we mainly have two. That's Python and R. That's for experimentation. But when it comes to productionizing, as my colleague previously mentioned, Matthew, they leverage on Spark a lot. Yeah, they leverage on technologies which are very good at manipulating big data. So for a start, Python is enough. If you happen to know R, that's also enough. And I think we say as a team is we really don't focus on the technologies, we focus on the solution. So we don't really care if you used C or C++ to deliver what you delivered. The thing for us is what is the metric showing? It's not really about the technologies. And I know Matthew now will come in and tell you, okay, this Java will probably execute better than Python. And so that becomes their problem. For us, it's the model I've built. Is it performing this way or is it performing the other way? And we pick the best. We really don't focus on the technologies. But if you're interviewing, obviously, I think it's good to understand data frames, just have an understanding of pandas. You need to understand matplotlib, I think, for visualizations. And then you have statistical libraries, which you need to know about in Python and in R. Yeah, those are the things you need to know. Can you make it as a top data scientist with limited potential in math? Wow. I don't know. I don't know what limited is relative. I don't know what limited means. Is it that you don't know, you don't understand standard deviations? Because no, if you don't understand some of the statistical concepts, then you're not going to make it far. But also, there's a lot of things in stats, but this stats is very big, so I don't know what you mean by limited potential. To be honest, I'll just say, just understand the basics, understand how to summarize data, how to present it, how to run experiments, how these machine learning models are built up. Because they borrow a lot from stats and you'll be good to go. How do you integrate projects done using different languages, Python and R? That's a data engineering problem, Matthew. That's what they help us with. But ideally, the way we expose our models is we build services. And in this era of microservices, as you know, it really doesn't matter. All I need to do is create an image of my project and anybody can consume it. It doesn't really matter if it was built using Java or R or whatever. All I need to do is build an image and then give that image to a team member maybe who is depending on me. But trust me, if you go in the data science route, Python is a go-to, and the reason we say that is the community is very big. So if you're looking at getting something, like if you're looking at doing something, probably it's already been done and you'll get a library for it. That's why most data scientists keep singing Python. It's because of the tools available to you. Yeah, what are the best sites to get messy data? That's a very difficult question. I don't think really messy data you can get if you scrap the internet. For example, if you go to like I know in my interview I had to scrap data off of a financial site. So if you scrap data off the internet, the data will be messy. But most of these sites, when they're presenting challenges, the data is very clean. But it's not as clean, but it's ideally clean. That's not the way like my environment that I work in is. But honestly, how you get messy data, I'm not quite sure how to go about getting that.
I have a question.
Yeah, sure.
You've mentioned that in your interview you asked about scripting. You script data from a financial site. Is it necessary for a data scientist to get to understand or to get to know web scraping skills?
No, even for me, it was very honestly. Even me, I wasn't quite comfortable scraping data. But this was a challenge that was presented, and I had to figure out how to do it. It's not. Let me say that was the last time I did that. But for companies, I know some companies in the US, like small startups who don't have data, will sometimes go to the internet and try to scrap data. So that question depends on who you're looking to work. If it's a startup, sometimes they might not have the data you need. But for us as Safaricom, we have so much data, so that's not a skill I've used. But yeah, I think it depends on who you're working for. I don't. It's not. Let me put it this way. It's not a key skill to have.
Okay, thank you.
I was actually lucky that I had about beautiful soup, which is what I used. I was actually very lucky because from all the people who are presented with that problem, actually, it was only two of us who were able to scrap the data, and it disqualified a lot of people. It's not a key skill, to be honest. And right now, the way we run our interviews, I don't think we've ever presented such a challenge again.
Was that the Safaricom interview?
It was. That's how I was interviewed. But that my setup was kind of, I went for hackathon, and they were also looking to hire, and so that was the challenge they presented, and you were supposed to work on it by yourself. But I have been in Safaricom for now almost 3 years, and we've never interviewing for a data science role, we've never asked people to scrap data again. So that's why I'm saying it's not really a key skill, but it's just a good tool. It's easy, by the way. It's very easy. Just go look up beautiful soup. Like that library makes it very easy to scrap data, but it's not something you need to focus on, to be honest.
Okay.
Somebody's asking. Yeah, sure, go on.
Sorry, I saw there's a question. I think Timothy Agavi has asked twice, but I think you have not seen it.
Okay.
So I'm also interested in it. When is the Safaricom internship or the interview process, or when do you recruit data scientists in your team?
So yeah, I know when was it? Last year we brought in interns. As a team we recruited some interns. Right now I don't know, because of COVID everything is very messy. I don't know how that is going to go on, but we had actually started that process. The easiest way right now to get into Safaricom, I think, is through the technology internship. And the thing about that tech internship is you get the chance to rotate around the teams, and you can actually say that I want to be part of the data science team, and you're probably going to have an opportunity to come join us. So I'd say that's the easiest way to get into stuff right now. I don't know if they're still bringing people on. Again, this year has been very messy, so I don't know. But look out for such opportunities.
Okay, thank you.
Yeah, you're welcome. Is Julia considered in data science modeling or like guys? I know even me myself when I was in school, I really focused on tools. I really focus, and I couldn't help it because of my software background. But focus on the problem. But all these things, NumPy, Pandas, TensorFlow, yeah, those are tools we use. It doesn't hurt to do them. I think if you go for an interview, they'll require you to. If they require you to showcase something, then you need to rely on them. But focus on problems, not tools. I see most job advertising hiring senior data analysts or people. Yeah, it's also a problem. I'm not also a senior data analyst, data scientist, sorry. So it's quite, it's tough. I know that. The thing about the market is they're really looking for these senior guys to manage teams, and it's also even very hard to find one good data scientist. And this was my route. I don't know if I made it clear. I joined a company as a software engineer. As when I'm working as a software engineer, I knew I loved data and I wanted to work with data. I started working with data analysts. Yes, so at one point I was doing two jobs. One as a software engineer and the other one is a data analyst. So as I'm doing that, I'm picking the skills needed to be an analyst. That's how you make yourself ready for opportunity. Sorry. And then after that, now I transitioned to being a data scientist. So what I'll say for people who are in school, for your first job especially, don't be very picky. Just go. Hata ukiitiwa peleka chai, I tell people, get yourself in the door, get inside an organization. It's easier for you to express what you want to be when you're inside an organization, rather than sitting outside waiting for people to advertise for data science roles. You know what happens is, yes, we have analysts in Safaricom who also want to move to being data scientists, and given that they have an upper hand, they understand how the business works, and they've shown that they can actually deliver. We'll consider them first when we are looking for this entry role. So that's why I'm saying, get yourself in the door. It doesn't matter what you're doing, and then while you're there, work towards now moving to where you actually want to go. I hope that makes sense. I see somebody said Scrappy and Selenium. Yeah, Selenium is actually very, very good. It says the usual data. Safaricom. Oh, the data we use for modeling is mainly transactional data, and for that, there's no. We can build our models without even tying it to bio data. And the thing is, the only limitation we have is as Safaricom, we're not allowed to ever share customers' data. But as an organization, it's just like Google. Google doesn't. Ideally, they're not supposed to sell your data with anybody, but they use that data to advertise to you, and that's the same model we adopt. We have your transactional data. We have network data, of which it's not tied to any human being. And we can now use that data to improve our processes and products. When it comes not to sharing data to third parties, that's when you need consent. As of now, that's the law we're operating on with. I don't know in future how it will be. I know there's been issues, especially with companies like Facebook, to allow users to give them consent to even use their data to advertise to them. But as of 2020, those are the laws we are working with. You once told me that it has taken me places. Faith. Mutua, yeah, I think I have answered most of your questions. If I haven't, feel free to type it. The moderators, I hope I haven't eaten too much of their time.
Hello.
Yes.
There's a question here.
Yeah, I can hear you. Yeah.
So, what's the difference between a data scientist and an actuary? Because you said that data scientists actually work for the future. It's like you're doing the future as at now. They work for the future as at now, which is also the same as what actuaries do.
Yeah.
So actually,
yeah.
What's the difference between
the thing about actual scientists? They're like data scientists, but their job was mainly focused on risk, averting risk, predicting risk. Does that make sense? It's like, okay, even like statisticians nowadays are called data scientists. So data science is such a broad term, and you find so many old roles are now inside what is now termed as data science. But I happen to understand what actuarial scientists do, and for them, yes, they do predict the future with the hope of averting risk, especially in insurance companies. Like, they want to know, like, if I give you an insurance policy, what's the risk to the business? Because we also want to make money, and we need to understand, if I give you an insurance for the next 1 year, how many accidents will you have? What are the chances you'll even have one accident? And if so, how much will it cost us? And that's what an actuarial scientist is doing. And ideally, as a data scientist, those are the kind of questions I'm also asking myself. But now, me working in Safaricom, I'm not working on insurance. I'm working on how can I build a recommender model to, for example, for Tumukiwa, to give our customers the better offering, like, and an offering which we know they're likely to buy. I hope that makes sense. It's somewhat the same. With these other guys more focused towards a certain kind of problems, and with now us on this other side, we're actually in the same umbrella, but us guys now, it's a bigger umbrella.
Actually, I'm also on the same boat with you, but I'm not convinced enough, because you also talked about modeling how many calls somebody is going to get within a given time, which seems to me to be like you're using more of statistical distributions, like the exponential ones, the waiting time processes and all that. So somehow I kind of feel like there is no huge gap between actuaries and data scientists.
Yeah, and that's the point I'm trying to cross. There is no huge gap. We're in the same umbrella. We're in the same data science umbrella. The difference being, these guys focus on a certain subcategory of problem. Okay, let me put it this way. We're using the same tools. But now me as a data scientist, I have more tools to work with. An actuarial scientist, Kitambo, they didn't have machine learning tools. Right now, data scientists have machine learning. We have our neural nets. Kitambo, these guys, they had very simple models. It's like asking me what's the difference between a statistician versus a data scientist. I will say data scientists deal with a lot more data, and they have a bigger set of tools to work with. Kitambo, statisticians that used to leverage simpler tools because of the technology. We didn't have the technology to handle big data, and we also didn't have this big data. So they were working with smaller data sets, and what they were using simpler tools, because when you're working with like 2 dimensions, data with 2 dimensions, then you don't need very complicated models. But with the current world as it is, you find that especially for problems like image recognition, we have tens of thousands of features, and for that we needed better tools. And that's how the field data science as is came to be. I hope I answered that question.
Yeah, yes, you did.
So we have a broader set of tools. They can still use our tools, and I think it would make their work more efficient, if you ask me. And they're still focused on one domain of problems, whereas we, on the other hand, I mean, like there's a domain depending on which job you're working on, but as a data scientist, you should be with your toolbox. You should be able to learn quickly about the domain and be able to deliver. For instance, if I was to go to a bank, I myself currently, I think I'd be able to do the job an actuarial scientist does. That was a good question. I think no more questions for me. This is very interesting.
Okay, thank you so much, Joyce. That was a very interactive session. My name is Mabel Karani. I was also one of the moderators, so I'm really grateful for what you taught us. It has been a great session. I'm sure most of us have learned. Personally, I'm in the journey towards becoming a data scientist, which from the talk you've given us, both you and Matthew, it has been really informative and great. You've mentioned many things, including one of my take home is that we should mostly focus on the problem instead of tools, because right now, okay, some people might be confused about what to learn, because when you Google how to become a data scientist, you get so many things. We learn Python, Python will become obsolete, learn Julia, learn, I don't know, so many things. So you've told us to focus on the problem, which is a very good thing, because the problem is what will guide you. Depending on whatever tool you use, if you're able to solve a problem, then I guess that would.
I think your summary is spot on. Like, at the end of the day, it doesn't matter how fancy of a tool you're using.
Yeah.
It really matters, is your model helping us make better decisions?
Yes.
That's it. Yeah.
Okay, so next we are going to have a presentation from Janet Wafubwa, but she isn't present. Her name is Janet Wafubwa, a senior data analyst at Safaricom PLC, but she will send a presentation or a PowerPoint, which I will share with you through email. I think I'd sent the email I used to share this link with. You can use this link to apply. It is in the RSVP form. If you hadn't filled it in, I can't get your email, so I will share with you the PowerPoint presentation later. I think with that, maybe you can have maybe 5 minutes for some of you, maybe to say in very brief words what you've learned from this session. Just 5 minutes, and the order will be, you'll raise your hand, then I'll pick just 5 minutes what you think you've learned or what you'll use in your knowledge. Then after that, I will give Matthew and Joyce maybe a chance to say their final word before we close. Then after, I will tell you what is in store for you for day 2, which is tomorrow. Then after that, maybe you can leave at your own pleasure. So I'll give 5 minutes. So just raise your hand. Tell us what you've learned and what you'll apply in your life or something like that. Yes, Stephen Kahara.
Okay, thank you very much. My name is Stephen Kahara. I am a student. Actually, I'm a postgraduate student, doctoral student, and also I'm working. I'm also interested in data science because my thesis is actually in data mining, and more so in the area of security. I'm grateful to the presenters, especially Matthew. Matthew mentioned about a number of tools that can be used actually in the work, and I've actually been sensitized, especially on some of these tools that perhaps I need to think about even as I do my work, as well as my studies. My only question to Matthew is whether I can have access to maybe a team that is dealing with security, because that is my interest. Perhaps I can be able to talk more about what I'm thinking and perhaps work as a project in terms of dealing with security in such systems using machine learning. Thank you.
Thank you, Stephen. Okay, yes, Matthew.
Yeah, so I just wanted to ask, when Stephen, when you mention security, do you mean security from the perspective of physical security, or do you mean security configuration of the tools? Say, how do you set up security in Hadoop and stuff?
Well, I'm looking at the issues of intrusions.
Okay.
Yes, now you understand where I'm coming from. And especially in large organizations of Safaricom, which deals with large data and a lot of penetration, intrusions that actually you receive. People try to hack your systems, as such kind of things.
Yeah, I think so. In terms of the actual implementations, obviously there will be a team, the security team, that handles that, and then the details of that, obviously, as I've mentioned a couple of times before, they are subject to non-disclosure clauses.
I agree.
But at the top level, all big organizations, what they do, they have one system that aggregates all the logs. So security is just a part of analytics, where and I can give a very quick example. If you host your web applications using either IIS, Apache, Nginx, any of those tools, they have their logs. Now, those logs, they at the very least show status codes, say status code 400 for forbidden. So that would be a very good beginning of your analysis. Now, there are some enterprise-grade tools that do log analysis, and I guess that would be a conversation for another day. But I know for sure that one of the tools that people use is called, just give me a sec. Yes, Splunk. I know that different companies use Splunk as one of their log aggregators, but beyond there, maybe I may not be able to disclose much.
Yeah, and kindly, if you don't mind, perhaps you can share with me your email. Perhaps we can extend this discussion further, if you can appreciate.
Yeah, sure. Yeah, definitely. I shared my Twitter handle earlier.
Yeah, but maybe an email will do. All right.
Okay.
An email, kindly, even if it's personal. Yeah.
No worries. I'm not a VIP. So
yeah. Otherwise, thank you very much for a very, very informative presentation.
Okay, thank you, Stephen. Thank you, Matthew. Anyone else, the last person who has anything to say? I'm giving you one chance, maybe what you've learned. You can raise your hand. If not, maybe we can have a final word from Matthew, then Joyce. Oh wait, there is Samuel. Samuel, you have 30 seconds or a minute.
No, okay. Mine is to Matthew again. As a question. I noticed the tools you mentioned. They mainly seem to be enterprise grade tools that somebody with a lot of hardware capabilities is actually required. But I wish in a presentation you'd actually mention to somebody who is a beginner the best tools that they can actually use. Because for me, if you asked me, whatever mentioned there, it looks really to you need to have a huge data set, which is very difficult to come by, and a large processing power to go with it. Thank you.
Am I allowed to respond, Mabel?
Yes, yes. Can you?
Oh, okay. So I just put up my screen once again. So the idea, as I mentioned, I think the only one thing that needs a lot of, probably needs a distributed setup is Hadoop. The rest of the things you can set up on your machine. And that's why I gave the example of, as a matter of fact, I was just playing around with something. Let me just pause this presentation to bring up something I was looking at earlier. So as you can see, this is my machine. This is my machine. I could do that. I have an environment. Environment has only these tools installed. It has PySpark. I could initialize PySpark right there. That means I can start writing my Spark applications right on my machine. By the way, as you can see, I'm on Windows, but I'm running WSL. So it's just a subset of the tools that need you to be on a cluster, and that would be only Hadoop. The rest of the tools you can run even on the smallest of the computers that you have that run Intel Celeron. Mabel?
Oh, you're okay. Sorry. Thank you so much, Matthew, for the for explaining that to us. Again, thank you, Joyce. It has been quite an informative session. Now I think we are done. Maybe you can say a few words before the end. We conclude this session, this part of the session. So we'll start with Matthew.
All right. So I think the one. Oh, sorry about that. I think the one thing I want to mention, and I'm just gonna stop sharing, and if possible, share my screen. You can see me clap once when you can't clap, so I won't hear. But I assume if Joyce smiles, I know she's seeing me. Okay, she's seeing me. Good and here. Okay. So there's only one thing I want to call out to you, to everyone. First, there's all this technology, there's all these things that we have to do. They are good, they are awesome. But be human first. At the end of the day, be human. The next thing is all these tools. You saw what I did on my other screen, PySpark and everything. They are nice tools, they are good toys, they are interesting. But if they don't deliver value to the business you work in, they are just bad toys. Ensure that whatever you are doing adds value, and that includes even the toy projects that you're working on. Last but not least, if you're trying to get into data science and you don't have any programming experience, as you can see, all these things mean that you have to come from somewhere. There's something we call the data science continuum. Like Joyce mentioned, analysis, we have people who talk about what happened, and that is insight. And then you're going to have people who talk about what will be, and that is the foresight. And then there are people who are going to talk about how do we influence what could happen. That is the continuum that we are talking about. And in all that, you are going to have to use technologies. It does not matter whether you are using Python, Java, R, SQL. It doesn't matter what you're using. Learn the first principles that have to do with what you're doing. If you're trying to be an advanced data analytics person, at least be able to think in an analytical way. Be able to analyze your data, even from Excel first. If you're trying to get into data engineering, we know that you can install, like I've done here, Pandas. I can install PySpark. But what happens when it fails? You may have heard of the word chaos engineering. You cannot deal with adversity if you cannot deal with the first principles. The first principles are, I installed Pandas. What is Pandas? Is it a library? Is it a module? Do I need internet connection? Do I need a distributed setup? Do I need a network? Those fundamentals will leapfrog you, and they will galvanize you even when technology changes, because as much as people might not agree, technology does not change as fast as we think it changes, because it's just the implementation of the technology that changes. The basics remain the same. Networking remains the same. Bits and ones and zeros remain the same. Understand the first principles. Thank you for having me.
Thank you so much, Matthew. We really appreciate giving us your time to gracing this summit. I'm hoping that all of us have enjoyed and they have learned a lot from your presentation and what you've taught us. So thank you. Joyce, you're up next.
Yeah, hi. First, I have to say I really love what Matthew has said. It's really true. But like most of us, and we have fallen victim of this as well, we get lost in learning new tools. And for a while, I was also that way. I wanted to learn everything. I wanted to learn what's new, what's hot right now. But at the end of it all, you're going to be measured by the value you bring, not the technology you use. It's the value you bring. And Matthew will tell you, for him, it's not about the Hadoop, the whatever he uses. It's about this process was taking 2 hours. It's now taking 10 minutes. That's value for the business. For me, as a data scientist, my value is measured by we didn't have a model, or rather we were using rules previously to this. The rules were giving us this performance. The rules were performing at 60%. The model I've built, is it doing more than 60%, or is it even worse than the rules? And in that case, then let's just have our rules and let's disregard the model. So again, it's about the value, and you should measure yourself against the value, not about the fanciness of the solution, not about the technologies used. So again, there's something called KISS. There's a very simple concept called KISS, and it stands for keep it simple, stupid. And I'll leave you with that. Keep it simple. Even when you again, I'll go back to when you're working, let the problem you're working on influence how you approach the solution. If there's a simpler way to do it that gives you the same result, stick with it. Keep it simple. Thank you.
Thank you very much, Joyce. That was very insightful for both Matthew and Joyce, that we should focus on what value we bring. Doesn't matter what how complex you know things, but whatever value you add, that will matter a lot. So thank you so much, Joyce, and Matthew, for that insightful information and for taking time to be with us today. We appreciate for being with us from 2:30 until now. It's approaching 5. So thank you very much. Like I said before, we were to have another presentation from Janet, but she wasn't available today. But I'll share a presentation that she wanted to share with us. So if you hadn't registered in the form, I have shared the link above. I can share it again. Okay. Yeah, I'll share it with you again. Maybe you can register, then I'll share the link, the presentation with you. So that is the end of day 1 for the Data Science Summit. I'm glad it was successful. I'm glad for the turnout, sorry. Thank you to all of us who've been here from the very start up to right now. And tomorrow is the day 2 and the final day for the Data Science Summit. Some of the speakers will be Kennedy Wangare. He's a data scientist at Safewater. The topic he'll be sharing is starting a career in data science and modern data tools. The second presenter will be Peter Ayub. He's a data scientist at Safaricom PLC. The topic he will be sharing with us is preparing to be hired by a tech hire as a data scientist. And the third but not least presenter is called Kigen Tembo. He's a data scientist based in Nairobi. The topic he'll be presenting with us is building a career in the data world, analytics, science, and engineering. So yeah, that will be for tomorrow's session. I hope that all of you will join. You can even bring your friends who are interested in the data science field. We'll be glad and happy that you'll be here with us and as we conclude the Data Science Summit. So that's all from me. I think we can end the meeting so you can leave at your own pleasure. Thank you.
Thank you. Have a nice evening.
Thank you.